back and forth. All right, Erin, can you hear me?
Yes.
Woohoo, that's great, thanks. All right, so I'm just gonna give you a little bit of background. I am Dr. Stephanie Ogren. I am the Vice President of Science and Education here at the Public Museum. And one of the coolest things that we get to do here at the museum is talk about the science and research that all of our staff do and that has been done historically and share that with the public. And so we're excited to have things like Fossil Camp where you can learn all about science and research. And we also have research teams that are part of international efforts to do science on the other side of the world. So our research team right now is in Paraguay. Does anyone know what continent that's on? You want to take a guess? Awesome. It is in South America. Good job, Fossil Hunters Camp. I love it. That's awesome. Yes, they are in South America. It's actually the exact same time there, but it's their cold season. We're here, it's our warm season. So it's pretty neat where they are. The other thing is they are literally 5,000 miles away. So they're really, really far away from us. See if I can get this to work. John, can you do the next slide? Once again, technology. We'll do just a minute. All right, so here is an image of where they are in South America. Paraguay is that little purple country, and Paraguay is a landlocked country. So that means there's no oceans, there's no Lake Michigan surrounding it. It is a landlocked country. But what they are studying there is some of the river systems and how fossils deposit because of those river systems. Paraguay has fewer people in the entire country than we have in the whole state of Michigan. So Paraguay has about 7,000 people in it. The whole state of Michigan has, or 7 million people. The whole state of Michigan has 10 million people. So that country has less people than our entire state. The region that the research team is in is a really dry, arid region. And so they're almost in this scrubby brush shrub area. It looks a little deserty. It does not look much like Michigan. And one of the neat things that I find, because I'm an aquatic scientist, because they're studying river systems, their river systems are the opposite of our river systems. So their river systems are called fluvial systems, where all of the water comes from one single point, a really big river, and then distributes into a fan or little rivers, right? In our rivers here in Michigan, we start with little rivers, and they all come together to form a big river. And so it's the opposite of here. And so they are looking at these really interesting river systems to try to learn more about how the fossil record or how fossils were distributed, currently, what that means for the past. So we're really excited to hear more about their research. All right, Erin, are you guys there?
Yes.
Awesome.
Yes. Thank you. Thank you so much for your introduction, Dr. Ogren. My name is Erin Koren. I'm the Director of Education at the Grand Rapids Public Museum, and I'm so excited to be engaging with you live here from Paraguay. I'm here with Dr. Redman and some other friends and researchers that I'll introduce you to as part of a paleontology research project called Future Fossils on Fans. Fan being the type of river system that Dr. Ogren was just describing. So we are going to give you a look at what a day of work and research looks like. I'll show you kind of some things that we have set up here, what we're working on right now. And then we're super excited to answer your questions and help answer maybe what you're curious about. So we really want your participation at the end. So to start with your participation, please raise your hand if you have ever been on a really long trip like I have. I came on a really long trip to come here right now. So raise your hand if you've ever taken a really long trip.
And I think we have about half the audience raise their hand.
Okay. Hands down. Raise your hand if you're curious about fossils. I am, for sure.
We have lots of fossil campers here, and they are excited.
Raise your hand if you are part of GRPM Camp Curious today.
Woohoo!
How many campers? And how about raise your hand if you like science?
Yay, best answers around.
Okay. Thanks for engaging. So I'm going to start introducing you to some of my colleagues here today. So first, I want Ricardo to come join me.
Hi all.
Will you please introduce yourself to some of my community back in Grand Rapids? Who are you and where do you work?
Perfect. I'm Ricardo Soberlitz. I'm from here, from Paraguay. I work at the Paleo Lab in the geology department at the Natural and Accurate Science faculty at the National University of Asunción. Our lab is very new. We only have almost 20 years, and I will part of the beginning of the lab when we create that.
Yeah, so Ricardo was part of establishing or creating the lab that he works in here. He's an amazing collaborator, an amazing peer for us. There is no way that we could get permission to reach these fields and these research sites where we're at. We wouldn't have half the knowledge about this environment, about the natural history here, about the paleontology here, if we weren't collaborating with our colleagues here from Paraguay. So Ricardo was also the very first person from his country, he told me last night, to present at the Society of Vertebrate Paleontology Global Conference. So that is super cool. Can you tell us like some of the fossils you have here in your country?
Yes, here in Paraguay we have different kind of fossils from different age. The oldest one we have is the Ediacarian one. Sorry. After we have the Silurian invertebrates, Permian plants and bones, some dinosaur tracks from Mesozoic, and finally we have a lot of Ice Age mammals at the Quaternary fossil here.
Similar to Michigan, right? We have some Ice Age Pleistocene fossils. So can you tell a story? You were also telling me last night about coolest fossil you were part of finding here.
Yes, for me, the coolest fossil we have on our lab is a giant sloth. It's called Scuvieri. We found in a cave in the north of our country. I think it's the most complete fossil we have because here in Paraguay, as you see, we have a lot of plants, forests. So it's difficult for us work in outcrops because we don't have a lot. So principally we work in channels and streams and small rivers. So when we found that fossils in the cave, it's very important for us because we have almost complete the animal. So for me, it's the greatest fossil we have.
Yeah, cool. So Ricardo is part of our team along with his colleagues Achi and Jennifer, and they work at FACEN, like he said, Faculty of Exact and Natural Sciences. So awesome expertise in geology, paleontology, and we've become super good friends through this, which is an awesome part of doing a long-term research project like this. Getting to come year to year not only helps build the data that we're able to have for our project, but also builds that relationship and builds that collaboration. Anything else you want to say before we move on?
No, enjoy the video, the live stream. We are working very hard here and please enjoy.
Awesome. All right. So we're going to go now next. We'll try to pan slowly, not to make you dizzy. And we'll go over to Alex Apgar. How's it going, guys? Alex, so can you first just introduce yourself to our audience? Tell us a little bit about where you're a student, maybe what area of science your expertise is in, and how far along in your program are you?
Yeah, absolutely. So as Erin said, my name is Alex Apgar, and I am a second-year PhD student at the University of New Mexico. I am super excited to get to do this amazing scientific work with my wonderful friends and mentors with the Grand Rapids Public Museum. And because I am in my second year of my PhD, I am about halfway done. So in 2 more years, after I have done a significant amount of hopefully really cool science, I will also be a doctor like Dr. Cory Redman over there. I'm super, super excited for that to happen.
Okay, so before we kind of get a close-up look at what you're working on today, can you explain where we are in Paraguay right now and maybe how this site is different from where we have previously been conducting our research for the last week or two?
Yeah, absolutely. So in the last week or two, we were towards what we call the proximal part of the fan system, meaning that's where it is one massive channel and it hasn't quite started branching off into its smaller channels just yet. Today, we are actually towards the medial and the distal part of the fan. So we're towards the very, very end where we're starting to get lots of different smaller channels as well as little lakes and ponds and streams, which is a great place to find things that have, unfortunately, in the past year, passed away on this side of things.
Awesome, thank you. So I'm gonna turn it over to you fully to kind of give us a glimpse of whatever you want to share with us about fossilization, how
Yeah.
that works, and then also what you're working on here.
Absolutely, for sure. So I am not only a paleontologist, I'm also a taphonomist, which means my field of study is taphonomy. It really focuses in on one particular part of the fossilization process. And I heard that we have a couple of folks in fossil camp that are experts on fossilization by now, but for anybody else in the audience that needs a brief refresher, essentially, when something starts to become a fossil, it's because natural decay cycles haven't happened. So that means that something died on a flat land surface like this one, and it got buried super, super quickly. So fast that scavengers and decomposers that usually eat those bones weren't able to get to it. And as long as those bones stay buried for thousands, hundreds of thousands, or even millions of years, eventually those bones will start to lithify, meaning they start going from organic bone to becoming mineral and rock. That's why we call fossil bones fossils and not just bones, because technically speaking, they're not bones anymore. They are rock and mineral 3D casts of what that bone used to look like. So what we're trying to do here, as I study the taphonomy of the animals that have died, is to try to figure out at what point in the process things start to change. The bones get buried to make them future fossils? Do they stay exposed to the sun for a long time? Does the stream itself change their shape and their size? Are there scavengers that are able to come in and take nibbles and gnaws at the bone before it gets buried? When we find that fossil later on, a couple million years into the future, we see those gnaw marks from the scavengers too, things like that. And you guys are actually just in luck because we found one of these specimens yesterday. So I've been going through our data collection process for this lovely guy. You guys can see there is a half-buried skeleton really, really close to this nice wet seasonal pond. And we don't see all of it because I think most of it has actually been buried by now. We're pretty sure that this thing probably died some point after April 2024. And from then until now, we got a depositional event. So the channel that was flowing out this way deposited a bunch of sediment, and that's what started to bury this fossil already. So it is about halfway through the process of becoming a fossil at some point. So I want to study it this year as well as in future years when we come back to see how fast it's being buried, how the bones are changing, if at all, and if the bones are staying together in the ground. So I figured I would walk you guys through what we do out here when we find a bone, because it's really important for us to not only get a good idea of what it looks like now, but we want to be able to find it later in future years. So every year that we come out to do this project, we are not only looking for brand new bones, we're also revisiting areas where we found bone the previous year to see if the bone is still there, if it's been transported away, or potentially if it's been buried where it was, like in the area where we are right right now. So I've got a couple of really handy tools that we all use to document these kinds of bone specimens. And the main one is this lovely guy. This is our field notebook called a Write in the Rain notebook. They're usually nice and bright yellow like this. And we use these notebooks specifically because Write in the Rain notebooks, the outside of the notebook as well as the pages in the notebook are waterproof, dirt-proof, mud-proof, sweat-proof, pretty much anything that would ruin notebook paper in a regular notebook won't affect my notebook here, so I won't lose any of the data that I've written down. So what we want to do first when we find a really, really cool bone specimen like this one is first and foremost get its GPS location. So that is a set of coordinates that I take once we have found this so that we can use that GPS coordinate to find this again next year. See if it's still here, see how it's changed, all of that good stuff. Then we want to get a description of the geomorphology. What is this area like? So that not only includes the fact that we are standing in an area where the fan has started depositing stuff at the very, very end of the fan, which we call a flood apron section of the distal part of the fan. It also includes that there's a very shallow seasonal pond here. It's very muddy. There's lots of very small vegetation and grass over there, and we're getting a good amount of footprints. All really fantastic information for us to know later down the line. We also want to know what it is exactly that we're looking at. So we can actually figure that out by checking out some of the bones that are out here at the moment. And I can tell you for a fact, because of these really awesome skull pieces here, that we are looking at a caiman, a relative of crocodiles and alligators, but usually a little bit smaller in size. We know that it's a caiman because its skull has these really amazing grooves on it that is what we call osteoderm texture. And osteoderm in Latin means skin armor. So a lot of crocodiles, alligators, and caiman have specialized bones on the outside of their body as well as on their skull to help protect them and keep them safe from attacks from other animals, sometimes other caiman. So this is a really, really, really long caiman. I'm excited about how big it is. Also want to know which of its bones are still out here. So over here, we've got its femur bone, which on us is this giant leg bone right here. We've got some vertebrae, which are its backbones, and some of them are over here, but really buried. And we've got a good amount of its skull. And if you guys look right here, you'll actually see this little curve. That's where its eyeball would have been. Super, super cool to find. We also look at things like what is the longest bone that we measure, because our right notebook have a little ruler on the side. So I usually use that to take that part out. We look at things like degree of exposure. Are there any trees or bushes covering the fossil at all, or is it out in the open? This one is obviously super out in the open. And we also look for things like burial. This guy is partially buried. Next year, it might be all the way buried. So next year, maybe I won't even see it anymore. We also want to see how things like exposure to the sun, exposure to potential scavengers that'll eat the bone before it gets buried, and how much sediment from the water is hitting these bones and sanding them down. So we'll also check out things like weathering, abrasion, and scavenging. Now, this guy is pretty new, so he actually isn't super weathered. The bones are still in really solid condition, and I haven't seen any abrasion either, which is kind of like the process where in a stream bed, when you're walking along and you look at the rocks are usually really rounded and smooth. That is abrasion, where sediment in the water is continually hitting those rocks, so it smooths it over time. The same thing will happen with the bones. I haven't seen a whole ton of abrasion here, but what I did see that's super cool is this thing has been scavenged. You can see usually backbones like this guy's have processes that come out. So here's a little one, and there's supposed to be a really tall one here at the top. But for all of these other vertebrae, the top section has been crunched off. It's gone here, 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 and here, which is something a lot of mammalian scavengers, especially like dogs and hyenas, really like to do. So somebody was nibbling at these guys. And there you have it. We have all of the data that we need for this lovely caiman that we will be able to visit year after year after year to see how he might eventually become a future fossil. Yeah, thank you so much, Alex. Yep. Careful. So we have a big crew out in the field doing what Alex described to find him. We've each got our notebooks, we've each got our GPS. We're gathering this data on bones. We return back to camp at the end of the day. We work really long days. We pack our lunch with us. We spend our whole day outside. We return back to camp and upload all of our data because we're interested year to year getting as much data as we can about these bones, maybe future fossils. And the research team is starting to analyze that data and figure out what can we learn from it? What inferences can we make about where and how fossils might be forming in this type of river system? We're super curious about it because we think it will tell us a lot that we can infer about the ancient past, right? How fossils that we find in the rock record formed, because they were probably forming in river systems very similar to this one. Thank you so much, Alex. Let's go visit Dr. Cory Redman, my colleague at the Grand Rapids Public.
Hey, Erin, as you're transferring, if you guys can stay close to the link, that would be great.
For the sound?
For the sound, correct.
Yes, perfect. All right, Cory, give us an introduction for anybody who doesn't know you.
Hi, everybody. Thank you for joining us in Paraguay, at least virtually. I'm Dr. Cory Redman. I'm the science curator at the Grand Rapids Public Museum, so I'm a little ways from home today. But I've been at the museum for about 7 years now, coming up. But I've been doing paleontology. My background is in geology, biology, with an emphasis of research in paleontology for longer than most of you have been alive in the audience. So I've been doing this a long time. I was invited onto this project by our co-leader, Jason Moore, who is at the University of New Mexico. That's Alex's advisor, who you guys just met. And we have been looking at the distribution of bone on the landscape in order to better understand why we find fossils in the rock record. Why do we find them where we find them in the rock column? And why are they in the preservation state that they're in? Today, I have been playing in the mud. So, as has been mentioned several times, Paraguay is very, very flat. So if you, Remy, want to just do a quick span, maybe not so quick, but you don't have a lot of topography when you work in Paraguay, as Ricardo brought to our attention. So since we don't have outcrop to work with, we create our own. And one of the ways we do that is we dig large holes to look at the soil or the sediment profile, because we want to look at how has the landscape changed through time. Now, it may not look like it, but we are actually in a channel as part of the Pilcomayo Megafan, but we are just at the very kind of distal end of the channel. So all the sediment that's being deposited here is very, very fine grained. Think like clays and silts for the most part, but we are in the middle of a channel, even though it doesn't look like the type of river channels that we have back home. But that's one of the reasons we're here, to study this river system, because we think the Megafan River system is a better example, or is a modern example, of the rivers that we see in the rock record that produces the fossils that we all love. So I'm gonna carefully get into the pit, hopefully not get too muddy. And I wanna show you some stuff that we found. The bottom of our pit is filling up with water because we have a small funnel near us. But what's really cool is so if you see this transition here, so you can see this is the modern surface. This is the surface today, ground surface. You can see the plant matter, right? Those are plants growing. And then from here to right here, you see this color change. You have this like brown to really black. That sediment was all deposited this last year. So since we were here in 2024 to now, this sediment was laid down, probably was laid down in a matter of days or weeks. So, you know, you can see it can deposit lots and lots of sediment in a very short period of time. This is 20 centimeters. So what I'm doing when we dig these holes is I'm basically describing how does the sediment change going down. And what's really cool is you can see this dark black here. That was the previous horizon on the ground surface in 2024. So this is where the ground surface was in 2024. This is where it is today. So we've had that much deposition at once, even though we're at the very end of the fan. So the way you do this is it's a combination of things. You're just making a series of observations, which is what science is all about. So you look at color, thickness, you want to look at grain size. So it's very clay, but you use something that's called a hand lens, and you just look for any kind of grain size. You want to look for any kind of sand, stuff like that. We look for any kind of bedding structure. So think of, is there any kind of structure to it? Think like ripples, maybe dunes, something like that. Give us indication of flow, flow rate, depth of water. We hit a really rich organic layer. That's where the previous grass grew last year. And then as you can see, if I get my shadow out of the way, it changes from
Oh, Erin, you guys seem to have froze. See if they come back on.
it's all about being able to reconstruct past environments. So we do this in the rock record all the time. In this case, we're doing it in the modern. It's just over a much shorter period of time, a couple years. We want to know, how did the environment change over the last couple years? And, we go back and survey for bones, the same area all the time. A lot of the bones that we surveyed last year in this area are now covered because we've had this much sediment deposition. Does that make sense?
Yeah, absolutely.
Hey,
All right.
Erin.
I think we.
Sorry, can I interrupt?
Yeah.
Just so you guys know, your video is frozen, but we can still hear you great. So I think if you guys are ready to do question and answer, we can do that just with audio.
Awesome. Thanks, Dr. Ogren. Hopefully we'll get our video back momentarily. Thanks for letting us know.
Sure. So we have your team did an amazing job. You answered a lot of the questions that we already had. So I'm going to just go over a couple of those, and then we have quite a few other questions. So one of the questions that was asked was all about, why do you hunt fossils so far away? And so maybe you could recap that. I know you talked a little bit about it, but maybe you could go over that again.
You think why we're in Paraguay doing this?
Correct.
Alex, I'm going to have Alex answer that. Why do we come all the way to Paraguay to study fossils here?
Yeah, that's a great question. We're mostly here in Paraguay to study how the fossils are forming in the rock record, even though we're studying the modern record, is because of that really fantastic fan system. So in the United States, like was mentioned earlier, we only have a different kind of river system where we start with lots of smaller streams and channels, and then it turns into one big long river channel. We have the opposite here. So we think that it's the opposite type of river that was depositing all of the sediment fast enough to bury things and turn them into fossils. So we needed to go all the way out of the United States, all the way out of most of North America, because we just don't have the type of river systems that we were looking for, that we think have been making most of the fossil.
Yeah. And if I can add, that's a really great question. I think it all ties into the fact that the deposition of sediment, the covering of bones with soil or mud is happening at a high rate here. And so when you think about fossils, dinosaurs, large organisms that have been preserved their full body in the rock record, we think what we're seeing here, how much sediment is being laid down in a short amount of time, this could be the type of condition where you could get a whole organism covered and becoming a fossil. Great question.
All right, thank you. We have a couple of questions all about your field work. So the first one is, how do you prepare to go out in the field for so long? What's the most surprising thing you have to prepare for?
Cory?
That's a good question. That's a tough one. What's the most surprising that you have to prepare for? It always depends on the field area. I mean, there's always challenges. The rule of thumb is when you're doing field work is something is going to happen that's going to cause you to have to change your plans. And you're going to have to pivot, and you're going to have to adapt to the situation. It's just whether you're doing field work in the U.S. or in a foreign country like Paraguay, there's just always something that comes up. The last couple of days before today, we were driving, we got 3 flat tires. Just the roads aren't necessarily the best here, so you have to make sure you got plenty of spares, and we can change tires out from one vehicle to the other. You never know what's going to happen. It always keeps you on your toes. But as long as you go into the field with that mindset, it's all good.
Yep. And I think of it like camping. We need to bring all of our food, all of our supplies, all of our first aid and safety things so that we can be safe no matter what comes up. All
That's
right, next
great.
question.
So try to be flexible is what I heard from those answers. Is it helpful or challenging when new people join your team, and how many people are on your team?
I'll answer this. So this year we have 16 people on our research team. Last year we had 12. Dr. Jason Moore from University of New Mexico has brought with us maybe 5 undergraduate college students. And this is an awesome experience for them early in their studies to get experience doing science field research. A bigger crew maybe has some of its challenges with grocery shopping. Our receipt from grocery shopping was as tall as Dr. Redman. So some logistical challenges, but it helps us cover a lot of ground. We can send different teams out and cover the site well. It's awesome. As long as people are helpful, they're ready to work hard, they're ready to be a good team member. That's what's maybe more important than the size.
Okay, so I have some more about your feelings. So some of the campers were curious how you stayed motivated and if you miss your pets and your family.
Oh, who wants to answer? How do we stay happy? How do we stay motivated?
Well, the actual nice thing about having so many people in our field crew is that you are constantly surrounded by other scientists that are excited about what you're doing and other fantastic friends. So it's really easy to have people to connect to, make jokes with, cook with, have fun with, and that can be really fantastic. Because of all the different people in our field crew too, you can sometimes get folks that see something in the field the way that the rest of us can't. They'll notice one little detail that I just didn't quite catch because I tend to study things differently. It's actually really nice as well to have the Starlink that we're using to talk to you guys, because even though our friends and family and even our pets are really, really far away, usually by the end of the day, we're able to call with them, sometimes FaceTime them and connect with them. We've actually been sharing a couple of the animals that we've found here in Paraguay with our friends and family back home.
I also think a good secret that our project leads say is a well-fed crew is a happy crew. So good snacks, candy or chips, some healthy food because we're working hard, but then good dinners that people make. Ricardo and some of his colleagues from South America have made delicious food for us. Can you tell us some things you have made or will make for us?
Of course, as Antonio said, very important for us is when we finish the day, we are very tired, we reach the camp, so it's important to have a dinner. So normally we cook groups, and the first day we cook like lentils.
Lentils.
Lentils,
So good. So
lentils.
good.
The second day we cook lenta, and today maybe we will have a very good barbecue for this part of the trip.
Here called asado.
Asado, yeah, we call it asado.
Really good meat on the grill, grilled
Yeah.
really well. We're excited for Ricardo to make us his asado.
Erin, just so you know, your
What?
video is back, so that's amazing. I think we have one. Do you have time for one more question on your Starlink?
Yes. Yeah, I think we have time for, we have about 10 more minutes of
Okay.
time. If you have additional questions, we would love that.
Perfect. We do. So, some of the campers really wanted to know what the coolest fossil you have found is.
So we are not searching for fossils here on this trip. We are studying modern bone. Does anybody want to answer like the coolest fossil you have found in your other paleontology experience?
Yeah, absolutely. I absolutely know. So, I also work in Petrified Forest National Park. So all of the fossils that I've messed with are primarily late Triassic, so 225 to 200 million years old. And last summer when I went out there, I found the skull of something called a phytosaur. So it also kind of sort of looked like today's crocodiles, but this one was much, much bigger. I found the entire skull. Some of the teeth were this big, and the skull was about this big. It was so unbelievably cool to see.
So, related to that, then, so what are some of the coolest bones that you found on this trip?
Ooh, that's such a good question.
Corey?
Yeah, that's a great question. What are some of the coolest bones we found on this trip? So it's kind of hard to beat Cayman. I mean, the skulls look really, really neat if you've ever seen a crocodile or alligator skull. We have also found capybara skull material, which is really cool. World's largest rodent is found here in Paraguay, South America, which is fantastic. Was it 2 years ago you found, Alex, you found the upper jaw of a varanic, not a varanic, what was the lizard?
Oh, the tegu.
Yeah, the tegu. So that's really cool. Big fan of the herps. So yeah, finding the upper jaws of the tegu were really cool.
Hey, Remy, Alex has pulled up,
Yeah.
if we can show it to our
Big
audience.
Photo. The coolest caiman that I ever saw while we were out here is almost the entire skeleton. There's only one bone at the tip of the tail missing. It still had its skin on it. It was so cool to see.
That visual came up really great. Thank you. So, so I guess there's a couple questions mixed in here, so I'm going to try to make them together. How many years do you plan on going out in the field to do a good study? And then what differences do you note from year to year?
That's a really great question. So this is the 4th year of this project. So the 4th summer of returning here to these sites. This is going to be hopefully a long-term research project, 20 years.
Yeah, we're shooting for 10 to start with, but the longer the better. So the idea is we want a long time series to see how the landscape changes, to see how the bone is distributed on that landscape and the different sub-environments of the Megafan River system. Yeah, but we usually take it year by year because it all comes down to funding.
Yeah, funding. The other part of that question was really good. It was kind of what has changed year to year. We have been talking, I'll have Alex answer this. We've been talking a lot about how interesting it is to visit these research locations year to year, the same time of year. But right now, it's looking very different in some interesting ways than it looked last year. Do you want to give us a quick summary? What has been different this year?
Yeah, absolutely. So first and foremost, Corey mentioned that we were on a channel, and it doesn't look a whole lot like a channel or even the channel that we saw last year. So last year, we were actually walking along what we were pretty confident was a channel. So whenever a river dries out, I'm sure you guys have seen some of them. Usually the channel looks like there is a little dip here called a levee. The channel is a deep U-shaped scourge into the ground, and then it has one other levee and it flattens out on the other side. So last year we had 2 of us walking along the flat parts and 2 of us were in the U-shaped hole walking around. But as you can see, all behind us, the U-shape is gone. Everything here is flat. So that means that we've had enough deposition of that sediment that it completely filled the channel in and flattened everything else around it, which is so cool because we did not expect to see that in this part of our area this year. We were losing our minds a little bit yesterday. You will also notice that this area is super, super green. Normally, when we've been out here doing research in Paraguay, everything is very dry and there are really, really thick mud cracks, like 15 centimeters long that you could get your foot stuck in if you're not careful. But this year, it's super, super muddy. There's not many holes that you can get your feet stuck in, and there is so much plant life. This is way, way greener and way wetter than it has ever been in all the years that we've visited here.
Stephanie, do
Yes.
you mind if I wrap us up a bit, or do you have another one or two good questions
I
for us?
have one last question, and then that sounds great. So this one, I think we have some of our high school students here, we have some of our campers here, and there were quite a few questions that came in about how can I do this when I grow up? Like, what kind of school do I need to do? How could I do this? How can I volunteer? So sort of those future-looking questions.
Yeah, I think being at opportunities like this, science, STEM courses, I think also just developing your critical thinking and your endurance, being used to being outside, specifically doing this type of work. Paleontologists, most of our crew have pursued PhDs, so it's quite a lot of school after undergraduate college. Ricardo, though, has some awesome experience. He's a preparator. So he works as a preparator for his lab. And that was he went to Argentina to do like an apprenticeship, like a certification program that was maybe 3 or 4 years. But also, I was talking to Ricardo last night a lot. What advice would you give to young people, maybe in our audience at the Grand Rapids Public Museum today? What advice would you give them on maybe how to pursue a science career, or if they're interested, what would you tell them?
Yes. Sounds like a cliche, but follow your dreams. No matter what the other people say to you is difficult, it's not necessary. Choose the science or the career you really like because you do all your life that. So even it's almost, if the people say it's impossible, one example is here in Paraguay, before our laboratory, we don't have any kind of work in paleontology. So we start to zero. It's not easy. It's not short road, but you can do it. So if you like it, do it, and no matter what happens. So just follow your dreams.
Yeah, super inspiring. Somebody mentioned volunteering. Ricardo volunteered for 4 years in the lab before he was given a paid contract position. So school, putting yourself in opportunities like this to learn, volunteering is good. I'm going to close out with just Alex and Cory. Maybe how would you answer that question, or what advice would you give someone who wants to do this?
Yeah, so I mean, I think just to reiterate what everybody else said, I think that's great. I mean, there's a lot in terms of volunteering. There's a lot of community science programs out there that you can take part in. That's a great way to begin getting that experience. There's lots of different types of science. If we're doing, paleontology, taphonomy, modern biology, geology, but there's any number of sciences under the sun. So follow what interests you, what you're passionate about. If you want to do this for the rest of your life as a career, you're almost certainly going to need advanced degrees. You don't necessarily have to go for a PhD, but you almost certainly need an undergraduate degree and then probably some kind of certification or master's. But yeah, experience and just having a positive attitude and really being willing to work hard is probably key to being able to do something like this and just to succeed in life. Frankly, I mean, it's not
Okay, Alex, besides your amazing earrings, thank you. She has like a different pair of earrings for every day. What would you say?
I would definitely piggyback off what Ricardo said and notice that if this is something that you want to do, you're going to be really passionate about it. And even though it's something that's really exciting, you're still going to have some hard days. There are going to be times when you have a ton of homework and you're really just not feeling it, or it's a field work day and you've been walking for 6 hours and you're really tired. If this is something that you really love to do, harness that passion and use it for your motivation. It's a hard day. I'm going to use my positive attitude to get through. I'm having a tough time. I'm not quite sure what today is going to look like. I'm going to do my best, and I will do my best tomorrow. That passion can really get you everywhere in science and in life in general, honestly.
Awesome. Great answers. Hopefully, Grand Rapids Public Museum Group, you learned something. Maybe you were curious about something we showed. Maybe if you do have this interest, something here from this awesome crew inspired you. I think everybody has the capability. If you want a career in STEM, go for it, right? STEM is for everybody. Dr. Ogren, I wanted to say before we turn it over to you to close out our program that people can learn more about this project at grpm.org/Paraguay. Tomorrow, we're also doing a takeover on our Instagram, the GR Museum Instagram. We're doing a live event at noon at 12 o'clock. You can expect to see me. You can expect to see Dr. Cory Redman, learn more about a different type of field work that he has been doing here, meet some more of our crew. But we thank you so much for engaging with us. Awesome to feel connected back to you all at home.
Thank you, Erin and Cory.
All right, we're going to sign off, I think. Thank you so much.
Take care, Erin. Have fun. All right, for our GRPM visitors, thank you so much for coming and learning from Cory and Erin all about the research that they're doing. It's really exciting that the museum can do international research with people from around the world and then share that with our visitors and our campers and really learn about how science is done. Another really cool project Dr. Cory's working on is the Clapp Family Mastodon. So we actually were able to find and dig up a mastodon here in Michigan, and we're going to put it on display in September. So be on the lookout for that if you really are into fossils and bones and all of those exciting things. So thank you all for coming and seeing our friends, Dr. Cory and Erin, and we really appreciate it.